A little homework answers here before we go any further. Okay, I didn't know what that first question read, so I cut it off, so I'm not worried about that one. Let's go through the rest of them. Okay. On letter D, it works out that 7 is equal to 1 after I subtract the 3 x's. That can never happen. Therefore, there is no solution to the first one. You would not write 0. You would write no solution. Okay. Number 3 is a very important question, particularly number 3A. What makes 3A so important is we talked about how if students stack it vertically, for whatever reason, a lot of students get it wrong. But if you take the time to change all the signs and show that first step, and then turn around and combine like terms, students get it right, whatever the reason. So that's the correct answer for 3A, for 3B, and for 3C, you got to start from the innermost parentheses and work your way out. Anthony?
For 2D, why do you put down questions like that? Like,
Why do I put them there?
yeah.
To make your life miserable, Anthony.
There's no way to be miserable because just by telling, just by saying from the x's, I can tell that it's not equal.
Oh, you're talking about D up above. I thought you were talking about number 3. The reason I do it, you know what, Anthony, that's a great question. Years ago, I had a guy who taught me how to coach baseball, and he said something to me. His name was Coach Grimm. And he said to me, the more you make practice like the game, and the more you make the game like practice, the better your team is going to be. And letter D is the kind of question that they could slip in on the Regents exam. And what I don't want to do is like do it once one day a long time ago and never do it again. And then lo and behold, one of them pops up on the Regents. And a question like that, if you haven't seen it recently and you haven't gone over it, that can make you panic as a student. Because you'll think you did something wrong. And you didn't do anything wrong. You're doing it exactly right. So I want to make sure that it stays fresh in your mind so I don't worry about you getting into a state of panic on the Regents. If you ever look at your tests in any subject, or the Regents or whatever, it tends to work that you get a whole lot right in a row, and then once you start missing them, a lot of kids, not all kids, but a lot of kids will get a bunch wrong in a row. And it's because they're thinking about the one that they got wrong a little while ago, and they can't concentrate on the present one that they're supposed to be doing. So I like to walk into a test fully prepared. No room for wiggle room. I want everybody to be ready for everything. Okay, letter C is an important question. Always work from the innermost parentheses on out, okay? We talked about number 4 a couple of times last week. We want to make sure that you're comfortable with a question like that. That's a great question because it combines order of operations with all 3 laws of exponents. So you really have to know a lot to get that question right, okay?
Wait, for 5, why didn't you square root the
Because I'm solving for H. If I was solving for R, I would square root, okay? Spencer, how you doing given that you did your homework so quickly?
Pretty well, actually.
Nice. Pretty well is like, average is the enemy of greatness. Never forget that as long as you live. I know you're a big Donald Trump fan.
Me too.
I was watching, I know, Ann. I was watching this video of Donald Trump on like one of these shows like Oprah.
Oh.
And this girl in the audience raised her hand and she wanted Trump's advice. And she said to him something like, I know I'm only an average person. And he said, stop right there. That's your problem. You're great. Look at you, he says. You're wonderful. You've got a great smile. You project yourself beautifully, but you think of yourself as average. He says, it's not about average. You're better than that. And we can't allow ourselves to think of ourselves as okay, so-so. We are better. Whether you like Trump or not, he's got a really good point when he says that. Okay. Here's my graphs. And here's the rate of change question. I'm particularly interested in the rate of change question because that will appear on virtually every Regents exam. And I'm hoping that you're getting that right consistently now. Are there any problems with the rate of change? Okay. Now let's go to the next homework page. And this is the word problems. What we've been working on a lot this particular chapter. And I want you to pay attention to a few things. I didn't do it for all of the questions because I like Spencer, I did this very quickly. But on the first question, I made it a point to underline things, I made it a point to circle things, all the things that were important in that question. I'm wondering, did anybody forget to put the area on number 10? Yeah. I think if you circle, you don't forget. You know what I mean, Carissa? Okay. It's not that it's hard. Clearly, if you get 7 and 20, 7 times 20 is 140. That's an easy question. It's just that we forget about it. All right, any other questions on number 10?
No.
Nice. What about number 14? Don't ask me why I went from 10 to 14, but I did. Your math teacher does know how to count. Okay. Notice how when I get an answer like 18, I circle it, I draw a little arrow to it, oldest sister, making sure I'm answering what the question wants. Okay. Any questions? Yes?
For number 14, I got 17.
You got what?
I got 17.
Did you do n plus 2 and n plus 4?
I got 15.
I got 15.
I got 16.
Bruh.
Oh, yeah, I didn't have
Did you do n plus 2 and n plus 4?
No, I do not.
Okay, well that would be the first mistake because it says consecutive even, so that means n plus 2, n plus 4.
Wait, no, wait, so
14. How did I get 14?
14 is the, see, now that's the kind of thing that kicks you in the butt. Listen,
Oh, 'cause it's
the
the
answer
oldest
is
sister.
14 if you want to find n. What does the question ask for?
I gotta start reading this.
Yes, that would be so helpful. Everybody, what does the question ask for?
How old is the oldest?
That's right. So if you worked out to get n equals 14, you're doing a great job. You just didn't answer the question. Okay? You had to include in that 14 plus 4 to get 18. Yes?
So when you're doing even integers, it's 2, like you add 2 and then you add 4?
Yes.
And then when you're doing odd, it's you add 1?
No. You add 2 and you add 4. Guys, listen, stop. This is a little awkward at first, but once we do it a couple of times, it makes perfect sense. Carissa, what is your favorite odd integer?
1,
1. What's the next odd integer?
3,
How did you go from 1 to 3?
add 1,
No, you did not.
2,
Yes. All right. Now, after 3, it's
5,
good. How'd you go from 1 to 5?
add 2. Oh, sorry. I thought you were going to say 3.
How much do I add?
4.
That's right. So I go up 2, I go up 4. Look, guys, I wish that I had I wish I had it drawn out here. Ready? Look at me. Watch. Watch my finger. Ready? Odd, even. Odd, even. Odd, even. Do you see how when you write the numbers out, you're always skipping one to get to the next of the same kind? Right? So that means you have to go up by 2s, not up by 1s. So I know it seems weird that it says consecutive odd, and then you do n plus 2, n plus 4. But isn't it true that if you did an odd plus an odd, you would get an even? So how could you get consecutive odds? For example, let's do 1 plus 3. What do you get? 4. Let's do 1 plus 2. Now you get 3. So an odd plus an even gets you back to an odd again. So it has to be n plus 2, n plus 4. So here's the deal. If it's consecutive, it's n plus 1, n plus 2, n plus 3. If it's odd or even, it's the same. If you just remember that if it's odd or even, it's the same. And the evens are so easy to remember, n plus 2, n plus 4. You get it every time. Okay, ratio problems, if you just remember to put an x, they're really easy. Okay? Again, I did a quick little check. I showed they add up to 180 right there. And another ratio problem. Oh, this isn't ratio, I'm sorry. Some students will do this. Take a look at your papers. Some students will just write 3x plus 5 equals 45. Bless you. Look at your paper. Did you do that? Did you write 3x plus 5 equals 45? Because it's not. Together, to get the whole length of rope, you need 2 pieces. One of those pieces is x. So you have to do that x plus the 3x plus 5 equals 45. And then you add them up and get it. Yes?
If you just like automatically like add the x's together and you just do 4x plus
Yeah,
5,
so you skip to 4x. Yeah, that's even better.
Okay.
Carissa brings up a really good point. She says, look, I'm just doing it in my head. I just made it 4x plus 5. Could have done the same thing with the one before that and come up with 12x. I show the step for teaching purposes. That's also why I put the little hoops underneath. Purely for teaching purposes. You do not need that in how you write your answer. Okay? Any questions? All right. So, those are the answers to the homework. Now let's get going on today's lesson. And I think today's lesson is just more word problems, right? Just things to think about. All right, so, turn to the section after to do it. All right, so if we turn to that section after to do it, it's the inequality problem. And if we read the bottom of the page, unfortunately, I don't have the ability to project this on the screen right now. Hopefully I will the third period. I don't know where the file went. I'm pretty sure it's on my other computer though, so I have to pull it up. Lisa brought half of her savings to the bakery and bought 12 croissants for $14.20. The amount of money she brings home with her is more than $2. Using inequality to find how much money she had in her savings before going to the bakery. Write the inequalities that represent the situation and solve it. Play. Go ahead, work on it for a minute or so, 2 minutes. It might be 3 minutes on that one. Bless you. Okay, so here you have, I should still have my glasses on. Anyway, if you take half of her savings, I'm gonna use an S for savings, and whenever we do something like that, we write the S in script so it doesn't look like a 5, okay? If you take half of her savings, and then I subtract 2 from it, it has to be, because it says here that he spent what, greater than, or is that at least half, right? Half of her savings to the library. To the bakery, I'm sorry. Half her savings to the bakery and bought 12 croissants for $14.20. The amount of money she brings home with her is more than $2. Half of her savings to the bakery and bought 12, and she has at least $2 to bring home with her. Okay, so it's gonna have to be, because she has at least half of her savings to bring home with her, $14.20. Okay?
Why are you subtracting 2?
That's a great question. The reason I'm subtracting 2 is because at the end of the day, that 2 is part of the half, agree? Because she's bringing home, she only spends half of her money, or took half of her money out of the savings account. So what I need to do is realize that since that 2 is part of the half, it's gotta be greater than or equal to 1620.
I did that opposite.
Right, then you multiply by 2, and the bottom line is that the savings has to be greater than or equal to $32.40.
But I still got the same answer.
Yes, exactly.
How does that work?
Yes, I agree. All right,
Oh my God.
because you just realized that since the half of the amount in the savings account was equal to, included the fact that there were $2 left over, I have to get the 2 to the 1420.
Why couldn't-
Now, if you put it in there right away, like Lipstick did, and you make 1420, 1620, or if you add the 2 later, it doesn't make a difference. It works the same either way.
I just subtracted 14.20 from 1/2.
Okay, all right, so that's one way to do it, okay? Not meant to be overly difficult. If I was to graph it, it would be 3240. Fill in the circle because a little line underneath, arrow to the right. Okay, turn the page. Let's write 2 inequalities for G and H. Go ahead. Little review on graphing those guys. 2 inequalities for G and H. Okay, so for G, we'll get this. -3 less than or equal to x, less than or equal to 4, or if you use bracket notation, it would look like that. Right? Remember, if it's a bracket, you're allowed to equal it, and if it's a parenthesis, then you can't equal it. Go ahead.
How do you know if it's gonna be less than or equal? I mean, less than or greater than?
Anytime it's bounded, because like the shaded area is the area in between. So if you're shaded in between these 2 areas like this, that means you're bigger than this guy, but you're smaller than that guy. So when you write this symbol, this means the x is bigger because it always points to the smaller number. And then this means the 4 is bigger. So this means the x is, if you just covered this up, x is less than the 4, but x is also greater than the -3. So I'm saying the 2 things simultaneously. All right, H goes like this. X is less than -4, or, because this is the walk like an Egyptian guy, x is greater than 0. No or equal to underneath. Okay? If I tried to write this in bracket notation, I could do it kind of like this. -infinity, -4, 0, infinity. So in other words, I would write 2 different brackets. One bracket to represent the part of the graph on the left, and one bracket to represent the part of the graph on the right. Make sense? Okay. Mercury is one of only 2 elements that's a liquid at room temperature. Mercury is a non-liquid for temperatures less than -38 or greater than 673.8. Write a compound inequality for which this is a non-liquid. So x is less than -38, or x is greater than 673 that's a 6, 8, and it doesn't say it's allowed to equal it, so it has to be strictly less than and strictly greater than. Make sense? Okay, we're all good on those. Okay, let's go back to today's do it. When we look at the do it for today, last thing we need to cover. Mariah thinks the following rule should always hold true. Should it? Find evidence for the following equivalency by substituting values for a and b. Is it always true that a plus b squared equals A squared plus B squared. You know, I see these geeky things on Facebook and on the internet all the time, and they make me kind of laugh. And I saw this one cartoon where this very geeky person, like straight out of the Big Bang Theory, this very geeky person was like laughing behind another person's back. They think that A plus B squared equals A squared plus B squared. And the truth is that unless the A or B is 0, this is not true. Okay? Never even close to true. It's A squared plus 2AB plus B squared. And we will get a little more into that later on. In fact, I'll even show it to you very quickly. Let's do what they said. Let's use two values for A and B. Let's use 2 and 3. If I do 2 plus 3 squared, I get 5 squared, which is 25. Everybody agree?
Yep.
Okay. What's 2 squared? Plus 3 squared. What's 2 squared?
4.
4. What's 3 squared?
9.
9. And 4 plus 9 is?
13.
13. Clearly 25 does not equal 13, so they are not going to be equal. But if we did this using double distribute, if I took A plus B squared to mean A plus B times A plus B, and I just do a little work here, double distribute the A's, distribute the B's, I'm going to get A squared plus AB, plus, this really looks like BA, but it's the same thing as AB, just a commutative property, plus B squared, and that gives me A squared plus 2AB plus B squared. So that's what it really equals. It doesn't just equal A squared plus B squared. Very common mistake. Now, I mentioned it today, and you will completely forget that. You meaning just about all of you. And then later in the year, we will come back to it when we do some factoring, and you'll go, oh, yeah. And we'll remember, okay? All right. Next up. And I just did the distributed property stuff right there. John makes lures for a fishing company. Over 2 days, he makes 71 lures. The first day, he spends much of his time preparing. Second day, he makes 9 less than 3 times the number he makes on the first day. So, first day, second day. And these can be very tricky until you get pretty used to them later on. The first day, he spends much of his time preparing for the job. Second day, he makes 9 less than 3 times the number he makes on the first day. So I call this n. The next one would be 3n minus 9. Now, then it says how many does he make on each day. Here's the problem. A lot of kids do this. 3n minus 9 equals 71. Remember, less than is last shall be first, first shall be last. 3n minus 9 is 71. Tons of kids write that all the time. But that would be if he made 71 lures only on the second day.
You have to add.
That's exactly right. Nice work, Evan. You have to add an n because the 71 was made on both days, so I have to combine the n and the 3n minus 9 together. So that gives me 4n minus 9 is 71. Add 9 to both sides. Die. 4n is 80. Divide by 4. N is 20. And that's the correct answer. For the first day. Oh, hey, that was supposed to turn green. 20. And the next day would be 3 times 20 is 60 minus 9 is 51. And if you notice, altogether, 20 and 51 add up to? And that's what you were supposed to get for your total, so you know you did it right. All right, any questions? Okay, you guys can start your homework. Cranking on that. All we're doing each of these days is review kind of stuff, so.
Don't. I don't like to.